Hi, my name is Victoria Kabat, and this is my Lab 2, Lines of Charge. So the purpose of this lab was to learn more about charges and their interactions with ordinary objects, but this time model that as a clear piece of tape with line charges. So this is a procedure that is similar to what we did in Lab 1, but now we're dividing up the E calculations into multiple parts and superimposing them to approximate a more accurate Q. This is because charges are not concentrated in one place, they're distributed along the length of the tape. So using the results, we find that the line charge method has a Q of 7.7339 times 10 to the negative 9, whereas a point charge method has a Q of 7.489 times 10 to the negative 9. The physics principles involved in this lab were Newton's second law, which allowed us to find the magnitude of force of gravity, Newton's third law, which allows us to say that the force of gravity's magnitude is equal to the force of electricity's magnitude because they are in equilibrium after distance d is moved. The law of conservation of charge allows us to find the U-tape's charge. The superposition principle allows us to find E net along the pieces of tape using the line charge method because we add each pieces of tape to find the electric field's total. And then the electric field relationship in Coulomb's law allows us to calculate the E fields. The experimental observations I had with the U-tape after I made the U-tape using a quick motion pulling off the base tape, I found that U-tapes and U-tape repelled, U-tapes and neutrally charged objects had partial attractions, and U-tape and a negatively charged pen made from my hair had a strong attraction. And since like charges repel and opposite charges attract, the U-tape is positively charged. The experimental measurements I had for my floating tape were that the tape's length was 0.201 meters, my mass of my clear tape was 2.01 times 10 to the negative 4 kilograms, and the distance I observed between my two floating tapes was 0.016 meters. My floating tape calculations using the point charge method we used in Lab 1 allowed me to make assumptions that each U-tape is treated as a point charge instead of the line charge, and that excess electrons are not distributed to nearby neutral objects, and that the tape has an equal charge distributed along its length, but we're treating it as a point charge. So the force of gravity's magnitude was 0.00197 newtons, and this is equal to the force of electricity's magnitude, which when you solve for Q, you find that Q is equal to 7.489 times 10 to the negative 9 coulombs. And then I used this to find more calculations, such as excess electrons, which is 4.681 times 10 to the 10th, atoms per the length of tape, which was 2.01 times 10 to the 9th, and then excess electrons to atoms had a ratio of 23.287. My computational method allowed me to use the line charge model, which I have presented to you on the right. So in the first screenshot, I have a screenshot that defines the constants and my E field function that I use in my code. And here I have Q, which is equal to 7.7339 times e to the negative 9, which was the Q that finally made my force of gravity equal to my force of electricity, which showed that they were in equilibrium. And then in the bottom screenshot, I have the iteration of my E field and showing how the top E field was made by the bottom tapes and how we're iterating through all the pieces. So this is a screenshot of my code when it runs. The white arrow represents the force of electricity, the yellow arrow represents the force of gravity, and then the green arrows represent 16 E fields that are coming from the bottom tape on the top tape. And then on the bottom of my screenshot, I have the magnitude of force of electricity, which is equal to the magnitude of the force of gravity, which are both 1.97181 e to the negative 3. My results summary showed that the interactions I have with excess charges have attractive and repulsive effects, and the two methods of calculations I used showed that Q equals 7.489 times 10 to the negative 9 coulombs using the point charge method, and 7.7339 times 10 to the negative 9 coulombs when I use the line charge method. This has a percent difference of 3.167%. So in conclusion, the approximations of charges differ because the point charge method assumes that all concentration of the tape's charge is at the center of the tape, whereas the line charge method divides the tape into equal pieces and uses the superposition principle to add each E field to find the total Q. Which value is more likely to be closer to the real value and why is the line charge method, because it uses a closer approximation by dividing the tape's charge into equally distributed pieces. Thank you for listening to my presentation, and if you have any questions, please leave me some feedback below. Bye-bye.